we're talking more graphing. We're going to change up parts of it. All right. Remember, domain is linked to your x values, your left and right values. Are there any limits to that? Range is your y, your up and down. Find the domain of this expression. So we're basing it on the x values, right? The smallest number that we can square root in Algebra 1 is 0. So we're going to take whatever's in the radical, and we're going to say that has to be greater than or equal to 0. It can't be less than 0. So take what's under the radical, x plus 3, and we're going to say it has to be greater than or equal to 0. Cool. Now solve for x. Minus 3, x is greater than or equal to negative 3. That's our domain. That wasn't too bad, right? This one's a little trickier. We have to take what's inside the radical and set it greater than or equal to 0. The lowest it could be is 0. We can't square root negatives in Algebra 1. So we'll add 8 to both sides. 2x is greater than or equal to 8. Divide by 2. So that would mean our domain is x is greater than or equal to positive 4. Wow, that was nice. Okay, all right. We're throwing on one more change here. We did our transformations yesterday, but now we're going to have a number in front of the square root. That's usually called a, and that's going to tell you if it's a stretch or a compression, if our graph's going to stretch out vertically or get compressed down and mashed down. It can also, if it's negative, flip that function upside down. It's called a reflection over the x-axis. So if you look, and again, let's draw our parent function on both of these. Remember, our parent function for the square root of x has a point at 0, 0, 1, 1, 4, 2, and 9, 3. That's the general parent function for y equals the square root of x. Boop, beep, boop, pop. We're going to perform some transformations on that, and it's going to change our graph. So if you look at this one, the x minus 1 shifts it all right 1. But that 2 in front, if the number is bigger than 1, that means it's going to stretch it vertically. It's going to make it taller. So we say that's a stretch. And you could say by a factor of 2, or you could just say by 2. So we're going to make the coordinates twice as tall. So we're going to take each one of them, and we're going to go to the right one, and then we're going to multiply the y, the up and down, by 2. Now here the y is 0, so we'll go right 1, but 0 times 0 is still 0. Let's try this. And you don't need to draw this on your paper, but let's just say I just shifted everything to the right one first. That would just show a shift to the right of 1. But then if we stretch them all by 2, we're making it twice as tall. So we're 0 times 0 is still 0. This is at 1. If I made it twice as tall, it'd be at 2. This one's at 2. If I made that twice as tall, it'd be at 4. This one's at 3. If I made that twice as tall, it'd be at 6. So if you want, you could do it in 2 steps like that. Otherwise, just move it to the right one and multiply the y by 2. Make it twice as tall. So now we're looking at that green line. We're thinking of our domain. Domain is left and right. Well, that's to the right one, so it never goes lower than positive 1. So we'll say x is greater than or equal to 1. The y is up and down. The lowest this goes is 0. Everything else is above that, so y is greater than or equal to 0. All right. Whew. One more, folks. The minus 3 shifts everything down 3. The negative in front of the square root means it's reflected. So all the coordinates, you could say, are like times negative 1, but let's say we reflect it first. Just reflect it over this x-axis. So it's like a mirror. So 0 times negative 1 is 0. This is at 1 times negative 1 would be negative 1. Here's at 2, so that would be negative 2. is at 3, so it'd be at negative 3. So here is just a reflection, but we also have to take that reflection and drop it down 3. So if we took this green line and we moved everything down 3, so that blue line would be our final answer. It's got the reflection and it's dropped down 3. You could drop it down 3 first and then flip it upside down. That's fine too. Domain is left and right. The furthest left it goes is 0. So this is our first one where the y is different because the highest this goes is negative 3. Everything else is less than that. So we'll say y is less than or equal to negative 3. And we're done graphing radicals. And we're done graphing the radicals.